I have to give you some terminology first. We're going to be talking about series and parallel circuits. A series circuit, two resistors are in series if there's no junctions between them. If all the protons flowing through the first circuit, I know it's not really the protons, but let's pretend it is. If all the protons flowing through the first resistor have to flow through the second resistor. Which of these two pictures shows resistors in simple series? Top one or bottom one? Okay, circle that. Example 2. What if you wanted to rewrite that circuit, which has three resistors in series, R1, R2, and R3, as its mathematical equivalent, one battery, one resistor? What if you wanted to combine those three resistors into one? How would you do it? I normally derive this, but it's a Friday, it's before a long weekend, I want to give you more time to work on the homework. I'm going to give you the punchline. If you want the total resistance, it's the first resistor plus the second resistor plus the third resistor. If there was 4 of them in series, you would just add the 4th. In other words, if we put numbers on here, if this is 3 ohms, and this is 5 ohms, and this is 12 ohms, what's our total of that resistor?
20.
Now, supposing I told you that this battery here was 40 volts, and I said to you, tell me the current and the voltage drop in each resistor. How would you do that? Well, you would say, first of all, which way is downhill? You would say, I'm looking for total current. I don't see an I amps anywhere. I don't see amps anywhere. I don't see amps anywhere. I don't see amps anywhere. You would say, do I know 2 things? No. Oh, I didn't mean to erase that, Mr. Dewick. Do I know 2 things? No. Do I know 2 things? No. Do I know 2 things? No. Ski. How many volts? 40?
40.
How many volts do I lose there? Don't know. How many volts do I lose there? Don't know. How many volts do I lose there? Don't know. So the steps I taught you yesterday don't work. The final step, if all else fails, you rewrite the circuit as its mathematical equivalent. What can these 3 resistors be replaced with? 1 resistor of how big? So underneath here, let's do 40 volts, and I'm so lazy, I'm just going to write 20 ohms. I'm not even going to fancy schmancy circuit. This is a rough sketch. This isn't a proper circuit diagram. This is where I'm going to do my little scratch pad. How many volts? How many ohms? How many volts do I lose in here then? How many amps must be flowing through here? So what is Ohm's law? V equals what times what?
I times R.
What we're going to use this is this. I total equals V total over R total. Caleb, redeem yourself. What's the total voltage? What's the total voltage from the battery?
Oh, 40.
What's the total voltage? It's meant to be
Yeah,
really
40.
stupidly obvious. Thank you. What's the total mathematical equivalent resistance?
20.
How many amps are leaving the battery?
2.
Do I know the total current leaving the battery? This question's going to fall apart. This is why I taught you that method, because now, how many amps through here? I know 2 things. How many amps in R2? I know 2 things. How many amps in R3? How many volts do I lose in R1? 6 people. It's I times R, right?
6.
I times R, right? How many volts do I lose in R2? 10? Now, there's 2 ways I can get the voltage in R3. I could say 40, take away 6, take away 10. I still got to get rid of 24 volts. Or am I also going 12 times 2 is 24? I got 2 ways to get the right answer. And now this circuit is solved. I could also find the power loss in each one by going V times I. This is going 24. Did I say 20? 24, Mr. Duke. And I could find power if I needed to, V times I. This is going to be our strategy. As our last resort, we'll rewrite them as their simplest mathematical equivalent. So, in the box on the next page, if you're adding resistors in series, R total is R1 plus R2 plus R3 plus R4 plus R5 plus... And I think I did put that formula on your formula sheet this year in the circuitry section. I never gave that last year. I made the kids memorize it, but I'm being nice this year. So, example 3 says, select the best answer for the voltage drop across the 20 ohm resistor. 100 volts, more than 50, less than 50, and convince me. You know what? I don't even have to go less than or more than. I can figure it out. These two resistors are in series. So here's my question. What's R total? What's the total current leaving the battery then? You're all looking too blank. I equals V over R. What's my total? And the reason I use the chairlift, this is the total voltage, has to be the only voltage source. This will give me the total current. What is the total current? It's going to be 100 divided by 25, which was what? Okay. So now, let's ski. How many amps in the 5 ohm? How many amps in the 5 ohm? How many amps are leaving the battery?
4. 20.
I don't. 4 amps leaving the battery. So how many amps here?
4.
I know 2 things. How many volts here?
20.
How many volts must I lose here? 80 because of the 100. Or I could also say, well, it's 4 amps, 80 volts, A, B, or C.
It's a C. Wait, what?
A, B, or C. And for your proof, right there. Okay? Can we bring it in a little bit? Psych it up a little bit? Because it's crucial. Thank you. Okay? So here, again, is a circuit that I cannot solve with the methods I gave you yesterday. I have to rewrite this as its mathematical equivalent. Because if I look, do I see current anywhere? That's really going to be your hint. They didn't give you any current. You're going to have to rewrite this. What can you tell me about these 3 resistors? They are in, I'm looking forward to being the letter S. So I'm going to rewrite this as its mathematical equivalent. R total is going to be what? Sorry? In other words, and eventually you won't need to do this, but for nasty ones, I still use this method. Underneath this circuit, really small, let's just rewrite it. It's 100 volts, but what did you tell me everything can be replaced with as a resistor? More specific, please?
25.
And I usually just write a little 25 ohms right in there. I could do the circuitry symbol, but this is what indicates to me that this is my rough note scratch pad. How many amps must be going through here?
4.
Okay, so we'll make a note in our notes. I total equals V total over R total. So it's going to be 100 divided by 25. So it's 4 amps. How many amps running through the 15 ohm resistor? How many volts do I lose going through the 15 ohm resistor then? 60. How many amps going through this 5 ohm resistor? How many volts do I lose going through it? Now I have 2 ways to figure out this. I could say also 4 amps, and 4 times 20 is 20. Or I could say, well, it's got to be 100 minus 60 minus 20. I got 20 left to play with. And the fact that I get the same answer both ways is must be right. Have to be right. Parallel is trickier. Pardon me? Okay. Resistors that are in parallel have junctions between them. This is simple parallel. These two right here are in series with each other because there is no junctions between them. I could combine those as one, and then I would have two resistors in parallel. So you may find sometimes it takes a couple of steps for a complicated circuit to rewrite it as its simplest mathematical equivalent. What's the expression for the total resistance of a parallel circuit? You know what? Let's call this left-hand resistor 5 ohms. Let's call this one 10 ohms. Let's call this one 20 ohms. You can't find R total. All you can find is its reciprocal, and everybody's going to get their calculator out. Of course, I didn't need to say that because my students would have had their calculators out already. Okay, keep it handy. Here's what we're going to write. We can find 1 over R total, and that's going to be 1 over 5 plus 1 over 10 plus 1 over 20. Don't go to your calculators. I'm going to show you the simplest way to do this on your calculator. And we may even be using a button that you've often wondered, why do I have that button? It's for this. And you'll notice this is important. Kyle, this does not give us R total. It gives us its 1 over. It's reciprocal. You all have somewhere a little x to the negative 1 button. That's your reciprocal button. So the best way to type this is to go 5 reciprocal, because that's 1 over 5, plus 10 reciprocal, because that's 1 over 10, plus 20 reciprocal, because that's 1 over 20, hit equals. That's not the answer. The reciprocal of that is the answer. Hit your reciprocal on your answer button. That's our total. I find I can't make these up nicely ahead of time, so from now on, I think last day we found we could do a lot of the questions in our head, or at least I was showing off and doing them in my head. That's not going to happen very often anymore. This is a yucky resistance. Our total is 2.857, and I would carry 5 or 6 sig figs, or I would use my answer button. $2.8571. Okay. Common mistakes. I've lost track of how many times kids tell me, oh, our total is 0.35. They forget to do the reciprocal. Or they go 10 plus 5 plus 20 and reciprocal that, forgetting to take the reciprocal of each one. Got to do each one at a time. And this, among other reasons, is why you have that little x to the negative 1 button. There are plenty of other physics phenomena that are reciprocals. By the way, you could also type, if you don't like your x to the negative 1 button, 1 divided by 5 plus 1 divided by 10 plus 1 divided by 20, hit equals, and then go 1 divided by answer, hit equals. I'm going to argue that reciprocal button is way faster. If you were lucky, you had a physics teacher last year who ranted about getting a good calculator. So, in the box here, I have parallel R total. This is wrong. It should say parallel 1 over R total, because that's what we find. It's 1 over R1 plus 1 over R2 plus 1 over R3 dot dot dot. Then take the reciprocal, the little x to the negative 1. I wrote something like that on your formula sheet. I think on the formula sheet, I just put 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over... Right? Okay. So example 7. Here's a lovely circuit. It wants me to find R total, I total, and then find V and I for every resistor. By the way, here, I don't think the current is going to split up evenly. It would only split up evenly if all of these were 10s. That's what we also said last day as a shortcut. If you happen to notice that all resistors are identical, the current will split up identically. Here, nuh-uh. If you gave me this, I would label downhill. I would look for amps anywhere. Don't see any. I already know I'm probably going to have to rewrite this as its simplest mathematical equivalent. But I would do a quick check. 2 think no, 2 think no, 2 think no. I can actually solve this as is by skiing. There's a loop. How many volts must I lose in that 10? Which means I now know 2 things. In your head, what's 60 divided by 10? This is going to end up being 6 amps, but we'll come back to that. I could also do this loop here, 60 volts through there as well. I think that's going to end up being 4 amps. 60 volts through there, it's end up being 3 amps. And that's how I would do it, because it's less work. But if I didn't spot that, I would say, okay, 1 over R total is going to be 1 over 10 plus 1 over 15 plus 1 over 20. Can I be really fussy, please? Do not put an equal sign and then tell me the answer, because the answer you're writing here is always 1 over R total, which means technically they're not equal. That's wrong. What you can do is draw a little arrow and then say R total equals. So 10 reciprocal, 15 reciprocal, 20 reciprocal equals reciprocal. I think this one might work out okay. What do you get?
4.615.
I don't think. Do you get 4?
Yeah, I got that.
Really?
4.6.
No, I'm calling you silly. Hang on. 15 reciprocal plus 20 reciprocal. Reciprocal of that. Okay. I'll write 4.61538. How about 4.6154? So what I'm saying, Sarah, is this ugly circuit up there mathematically is the same as 160 volt battery and one 4.6154 ohm resistor. You'll probably eventually, Lena, get good enough that you might not even jot down this little sketch pad mathematical equivalent circle, but I will in my notes so you know what we're thinking. I'd like to find I total. How can I find I total? V total divided by, it's all from Ohm's law. So it's going to be 60 divided by, of course, I'm going to write 4.6154, but what am I going to use on my calculator? Answer button. This might work out evenly, does it?
It does.
Okay. 13. I'd done some of the math in my head, and I thought we should get an even answer somewhere along the way. All right. How many amps leaving right here then? Oh, I wrote ohms. Amps, Mr. Dewick. Amps. I got to be careful with my units. How many amps leaving the battery, the chairlift? This question's going to fall apart. Now, I don't know how the current splits up, and splits up, but I can now use the skiing method to say, hey, how many volts here? 60 volts, 60 volts, 60 volts. How many amps did we say were in that first one? No, can't be 13. 6? How many amps did we say were in this one? Now I have 2 ways to get the final amperage. I could say, you know what? So far, I've used 10 amps out of 13. That far one better have 3. Or I can get there by going V divided by R. The same way I did here for each individual resistor, the I total works, the individual resistor works. Do we also get 3 amps? Do we get the same answer in 2 different ways? Great. Now let me be very clear. I would not do this for this circuit. I would have skied right away. And then to find total current, I would have said, oh, it's 6 plus 4 plus 3, it's 13. The only thing is, if they specifically asked for R total, this is the only way to find R total. Skiing won't get you there. Example 8. I like this question. This is a much more realistic question. It says, what can be said about the voltage drops across the resistors in the circuit below? You know, I'm going to find the voltage drop in every resistor. I notice a couple of things. Do I know the total current leaving the battery? This question's going to fall apart. And these 2 bottom resistors are identical. I think 2.5 amps, 2.5 amps, but I'll confirm that later. Are these 2 identical? That ratio trick that I said that I never bothered memorizing, I might be able to cleverly do something. Forget it. I don't need it. Are these 2 identical? That ratio trick that I said I never bothered memorizing, I'm not going to use it, but this might be in a 4-to-1 ratio. I don't know. It might be 4 amps and 1 amp. I don't care. I'm going to figure this out. How? I'm going to rewrite this as its mathematically simplest equivalent. Now, how am I going to do that? I'm going to be organized and lazy at the same time. Ooh, I don't know how big the chairlift is, do I? I don't even know the battery. What can I replace these 2 resistors with? How would I turn these 2 into 1 resistor? Are they in parallel? So it's going to be 1 over 10 plus 1 over 15 reciprocal. Do that. I think this works out evenly. 1 over 10 plus 1 over 15 equals reciprocal?
No.
So you're telling me that's a 6 ohm resistor equivalent. And if I keep going and head down, now I have these 2 in parallel. What's that the same as? 20 reciprocal plus 5 reciprocal. And on the bottom here, what are those 2 the same as? I think it's going to be 1 over 12 plus 1 over 12, which is 2 over 12. I think it's going to be 6. Double check me. Okay. Okay. I'm going to redraw this one more time because in my mathematical equivalent, what are these 3 resistors in? Series. So what's R total? I just add them. 6 plus 4 plus 6 in your head. So this is the same as 1 mystery battery with a 16 ohm resistor. This big ugly circuit, don't circle it, I will, is mathematically the same as that. Ooh, and I also know how many amps are going through this 16 ohm resistor. How many amps are going through this 16 ohm resistor? I know 2 things. How many volts is this uber resistor using up? You know how to find this, right? I see 80. You said 80. Oh, I thought you said 8. Oh, so how many volts must be leaving the battery?
80.
Let's put that on our original. I know the total voltage. I know the total current. This question's going to fall apart. Now, let's go back to our intermediate drawing. Right here, Sarah. Right here, Sarah. Right here, Sarah. Sarah, how many amps are going through this mathematically equivalent 6? How many amps right there? So how many amps going through here? Ooh, how many volts am I losing right here? I times R. Now this is this. Each of these must be a 30-volt drop because if you split up and meet up, you must be losing the same height. Knock, knock. I know two things. How many amps in this top resistor? 30 divided by 10, which suggests to me that the bottom one is going to be 2 amps because I got 5 coming in. If I go 30 divided by 15, do I get 2 amps? Cool, I got 2 ways to get the right answer. Tristan, in my intermediate drawing right there, which matches that section, are you seeing why I kind of make this looks very similar to what the original circuit is? And on purpose, I don't use the circuit resistors just so that my brain can easily spot this is the combination of those so I don't accidentally get resistors mixed up. This is me being me here. Tristan, how many ohms right there? How many amps are going through right there? How many volts does that section have to lose? How many volts? 20 volts, you said? 20 volts, you said. Remember I said I bet you it's going to be 4 and 1? Yeah. Volts. I'm bad with units right now. Thank you. Remember I said I figured it was going to be a 4-to-1 ratio? 20 divided by 5? Which means this is 1 amp, and if I go 20 divided by 20, I get double confirmation bias. Excellent. And in this imaginary 6 ohm mathematical equivalent, how many amps are going through there? Has to be. How many volts do I lose going through there? Yep. And I also could have skipped that step, and I could have said 80 minus one of these 30s leaves 50, minus one of these 20s leaves 30 in each of these. Or I could have said, remember I said I know that the current splits evenly between identical resistors. I could have just said, dude, it's going to be 2.5 amps. It's going to be 2.5 amps. And if you go 2.5 times 12, I times R, you also get the 30. So we're at a stage now, we've got 4 or 5 methods to get the last couple. Kirchhoff's law is very powerful. You wrap your brain around the current law, wrap your brain around the voltage law, learn how to rewrite parallel and series, and you got them all. All I can do is make more and more complicated circuits. I can't give you new stuff. That's a bit of a fib. In a couple of days, we'll ask, what if we add an extra battery? So, example 8 illustrates an important point. It shows us that the voltage drop across parallel resistors is the same as the equivalent. In other words, if you look up, here's the important point. The voltage drop across here and here are the same. The voltage drop across here and here is the same. And the voltage drop across here and here is the same. That's a nice shortcut and really helps you cut some corners if you keep your eyes open. This is why I said I really enjoy solving circuits. These are like little brain teaser puzzles to me. In a household circuit, the outlets, and by the way, I already had somebody in one of my other blocks, they were doing lesson 2, and they were saying, Mr. Dewick, why do I have something that's more than 100% efficient? Because you put the power coming out of the outlet in the in part of the efficiency equation. This is part of the problem of our vocabulary. Power into an appliance comes from the outlet. It does. Oh, smaller number divided by bigger number. Okay, back to here. If we connect in household plugs and lights, each of these plugs is actually wired in parallel. Each circuit has a circuit breaker, and when the circuit breaker exceeds 15 amps, most of the time, you have a couple of 30 amp mains, but most of them are 15 amps, the breaker will trip and no more current will flow. It's like flipping open a switch. So, if we connect a 1500 watt hair dryer and a 500 watt TV to the same circuit, will we trip the breaker? We have to draw this. Now, don't write this down, look up. if I was doing a direct current battery, that's my symbol for my voltage source. We're using alternating current, and there is a symbol that's supposed to be here, but it's vanished a couple of versions of Word ago. So can all of you pick your pencils up, draw a little circle. The symbol for alternating current is a circle with a little sine wave in it to show that the current goes forwards and back, forwards and back, forwards and back. But we're going to treat that like it's our battery. In other words, I'm going to write next to here, V is 120. And then it looks like I have one resistor here, that's the hair dryer. And I have one resistor here, that's the TV. And I tried to make them roughly the same width as the original drawing so I can really see how stuff lines up. How many watts does the hair dryer take? What did it say in the question? I've scrolled down. 1,200? And 500 watts for the TV? Which makes sense. I told you wattage is related to how much heat you're moving around. A hair dryer moves a lot of heat. It can even burn your hand. TV, not so much. I only know one thing. I guess I can't solve this. Wait. Ski. How many volts? How many volts? Now, it's alternating, so also if you go that way, it's acceptable. That's really the difference between alternating current, moves back and forth. But I'm telling you, it has to be 120 volts. How many amps? Because I know two things. What's the equation for power that has voltage and power and amperage in it? It's on your sheet. P equals VI, so I is going to be power divided by voltage. How many amps is that blow dryer taking? Really, people? It's got to be 10. Are you kidding me? Oh. Wow. Now, the difference between everything we've done so far is the 10 is going clockwise, then counterclockwise, then clockwise. It's alternating back and forth. Let's just pretend it's going in one direction. Okay? What if I ski this run? How many volts must I lose through the TV? This is why, by the way, your appliances are all designed to run off 120 volts, because that's what's going to go through them. How many amps? This one, I guess you can use a calculator for. 500 divided by 12. It's going to be either a 0.6 or a 0.3 repeating. 4.16. So, how many amps are heading right there, grand total? I got 10 coming this way. I got 4.16 going this way. Now, you could also say, or it could be going in the opposite direction. All I know is, what's my total current? I total is 14.2 amps. Are we going to blow a breaker? We're close. We're really close. You plug in anything else, and you're almost certainly going to blow a breaker. Okay. So this is how you can kind of figure out ahead of time roughly what you can run from different plugs. What did the question ask? Will we cause the breaker to trip? No, comma, we won't. Just barely. So, you're going to find in your homework more and more, before you can start to ski and use Kirchhoff's laws, you might have to rewrite the circuit as its simplest mathematical equivalent. I want to get you really good at these, which means, and the only way I know to get you really good at these is to give you lots of practice on these. So you're going to get lots of homework. Number one, absolutely. Number two. Number trois. Number four. I didn't give you the answers to number four. I'll have to go over those next class if you remind me. 6 is good. Skipped 5. Eight is good. I skipped 7. I'll skip 9. 10 is good. 11 is good. My brain is telling me that there's a problem with number 13, but I can't remember what the problem is, so I'm going to hold off on number 13.
You skipped
14 is good. Okay. I am willing to bet that there are few, if any of you, that have also already completed lesson 1 and 2 and 3 and handed them in. You have a long weekend. I guarantee, be sending an email update out tonight, or you can get everything in today in the remaining 25 minutes. You can probably get everything done and go home for the long weekend all caught up and understanding circuits so far. It's really cool.